Today it seems like it's a small class. I'm assuming people are either out or they're trickling in. I see now we have someone else come in. Well, anyways, I don't like wasting time because you guys are here voluntarily, so I would hate to hold y'all back. Good afternoon. Today is class 7 of Foundations of Programming. Yesterday we finished the previous lesson. I believe it was lesson 8, which was classes and objects. We went pretty fast on these last like 2 or 3 lessons. I'm not gonna lie to you. Uh, I think typically we're not done. We're like, well, the pace that we're on right now, we should have been done on Thursday. But you guys, I guess all of us as a whole got through it pretty quickly. So that says a lot about you guys, that you guys are really understanding the information and it's clicking fast, which has allowed us to move forward. Either that or I just talk really fast, and that's because I'm Mexican, so I'm sorry. Uh, Either one or the other, man. But either way, it's awesome. Which it just lets me add more stuff to the curriculum for further classes. Trying to see how um what we can squeeze in here. But yeah, so today we're gonna be doing lesson 8, which is gonna be importing modules, exception handling, and unit tests. It should be in the calendar. I updated it to reflect the pace that we were at. Uh, I think if you guys look at the calendar, today will be all of lesson 9. Lesson 9 will trickle over until tomorrow. Lemonade Stand is a pretty heavy assignment. It's kind of similar to the one you guys did for the streaming service, but a little harder. So if you remember, Eric, I told you he's gonna ramp up slowly. Lemonade Stand is kind of like the the last official assignment for class and objects where you kind of get an idea of like, okay, I see what he meant. And then the uh the pie game module that we're gonna be doing is kind of for funsies and stuff and to reinforce what we learn. But this one will be the last one that you guys will be on your own, kind of testing out yourself if what you are learning is sticking. But yeah, before we even start, how do you guys feel, man? Like a consensus overall, like you guys feel good with the material? Do you feel like we're going at a good pace? Do you feel like you're understanding the material? Um, what kind of feedback can I get?
I
No one
think for
has
me,
any.
it's
Go
yeah,
ahead.
I think it's like good. I think some of it's kind of fast, but that's like kind of normal. And I can go like review backwards, be like, all right, I didn't understand this too well, so like I'll go back and like study up on this before like the actual boot camp. So like it's definitely I know I won't get everything first try, but like the exposure to everything, it's nice because I like actually know, or I'm like actually seeing like, all right, we're gonna do this during like the actual boot camp itself, and it like prepares. I for me, like personally, for me, like I'm not doing this until like October, so it gives me like 4 or 5 months of preparation before like I actually like have to do it. I'm like, all right, I'll be like pretty good by the time I get there, so I can go review back on the slides, and the pace has been pretty good overall. So
Okay, yeah, it definitely does kind of give you some kind of roadmap to build up to for the immersive program. That is really good. Do you guys feel like I explained these subjects well enough? I know sometimes I struggle with trying to get my point across. Maybe I even go on a tangent, but I do encourage you guys if you guys don't understand what I'm saying or how I'm explaining it, please like do speak up. Let me know. Hey, you know what? It's not really clicking. I didn't really get what you meant by this. Would you mind, you know, using it in a different scenario or explaining it in a different manner? Would you mind drawing it out on the screen or something like that? Any
I
comments
wanted to
there?
say that actually yesterday's class on classes and objects actually really helped it click for me. I was struggling with the idea of classes and objects in JavaScript and Python because I first learned classes and objects from Java and it's really different. But yesterday's class and like the whole blueprint and stuff like that analogy kind of helped it click a little better for me.
Awesome, awesome. You say you started with Java, like Java, not JavaScript, Java.
Regular Java was the first language I started learning.
Yo, that sucks, man. I hate Java so
I
much.
know it's terrible. It's terrible.
Absolutely horrible. It's all built around classes and objects. Like that's the main program itself. And because of that, there's just so much you can do with it. And I guess you understood what I meant when you can privatize certain data members in Java, but you can't do that in Python. But yeah, I don't know. I hate having to typecast everything. It's so annoying, very specific, and then just running it through I forgot what it's called. What they call like the machine to before you actually run the program where it checks your syntax errors. That's always a pain. Uh, but it's a yeah, I can't
The
stand
compiler?
Java. The compiler, there we go. Yeah, I hate the compiler. Oh, I couldn't stand it. So I'm assuming you got experience with that too, Brandon.
Java's garbage, in my opinion. One of the most annoying things for me when I was learning it in college was just like having to declare everything. I think I joined when you were talking about that. Like even having to call a void function is just so annoying. Like I just don't want to do it. It's more typing. Um, it feels a lot better learning Python and JavaScript for sure.
Yeah, yeah. Eric, you got anything? I see you unmuted the mic.
Well, so just going back to the point you made about asking questions if you have them, I feel like that's the most valuable part of live instruction versus just watching videos and landing a tutorial help. Because like when I initially was trying to learn JavaScript, like objects and classes, just I was watching different people, and some people just suck at the way they describe things, or maybe they just describe it in a way I don't understand. But no, I think so far you've been doing a good job explaining content, so it's sticking with me at least.
Thank you. I do appreciate, and I do reinforce that if for whatever reason I do not explain it, or if I slur over my words, I do have a list. Uh, like let me know and I'll re-say. All right. But yeah. So without further ado, let's go ahead and move into the curriculum. Where is the share? My Zoom updated and everything is weird. How? I wish I could show you. Oh, here it is. I'm losing it. All right. So yeah, I changed the calendar to reflect the pace that we're on. You guys have been doing great with the pace. So we're moving forward. I'm gonna try to add a new lesson for Friday. But today and tomorrow will be heavily focused on LemonadeStand.py. But yeah, so lesson 9, importing modules, exception handling, and unit testing. You guys kind of got an idea of the importing module already with the import random. We kind of did that, backwards, but this will focus a little bit more on that. All right, so what is a module? All right, a module is essentially just a Python file that you can create that contains definitions of functions or classes that you would like to use in another file. Think of it kind of like separations of concerns like we did in JavaScript, where we had like one had CSS, one had HTML, and one had JavaScript. Well, we don't always want to have all this code of functions all in our main file. Sometimes it helps to create a separate file that stores all that, and then we can import what we need as needed, right? And that's where the module comes in. Right?
Excuse me.
Yes.
So when we import import regular expression, that would be basically be the regex module. Okay.
Correct. Those are like those are built-in modules that come with Python, which when you install Python, it was
Right.
installed to your computer. And then we can build our own. So correct. Yes.
Okay.
Right. So here we see a small little description. We have two code snippets, one showing the main.py, which tends to be like the main file that you essentially want to work on. And then they have the mystats.py. And typically, I take that back. Yeah, so we have main stats.py. And in the main mystats.py, we have a function here called find me. They went through they establish the function, declared it in that file, right? It takes an li, so a list, right? We declare a variable called sum. It loops through the list and then just adds all the numbers from the list into the sum and then returns it to you, dividing it by the length of the list, therefore giving you the mean. It has the function, all the functionality is in this file specifically. Now, they do that to separate concerns, not have it in our main file. And then we see here in the bottom code snippet, we have the actual main file that we were working on, and they're importing the my stats, right? You do not need the .py here, right? You just need, if it's in the code, the same directory that you're working in, all you have to do is just say like import my stats.
So if it wasn't in the same directory, would you have to like export it potentially, or do you have to export it all in Python?
You would use the file path, right? So like using the // depending on where it's at, whether it's like deeper into your directory or a level up. So you will use the syntax for that to find the path of it. Typically, you don't want to have everything just random anyways. So they're typically around the same area, either one folder down or the same folder or whatnot, right? So, and if typically as well, your VS Code will kind of assist you to, sometimes it will give you the file paths. It's a hit or miss sometimes on me, on mine, right? So they import the MyStats, which then gives the main.py full access to this function, and they're able to call the find mean function here, right? So they call the module MyStats.find mean, right? Because they didn't import the function specifically, they imported the entire module. So therefore, they call it by calling the module name and then the function they want to use from there, right? Import specific function or multiple. So here, on the previous slide, we saw that they imported the entire module. On this one, we see that they're importing specifically a function, not the entire thing. On line 1, we have from my stats import find mean, right? Therefore, it's only going to import specifically that one function, and then they're able to call it directly on line 3. Unlike on this previous slide, they had to call the module and then the function within that module. You're able to import specific functions that you need, because sometimes if you have a module with multiple functions, it's kind of, you don't want to import everything that you don't need. It's just a waste of time, right?
Hey, you're sounding like a robot for me.
do
Anybody else?
Are you guys good? I do have really bad connection this time, so I do apologize. How do I sound?
It's in and out a little bit.
Okay. Yeah. If for whatever reason it goes out and you miss something, just tell me to repeat it and I will. But yeah. So they import specifically that one function, and then they're able to call it directly. On the bottom code snippet, we see importing of multiple functions. They say from my stats import find mode, comma, find mean, comma, find mean, find median, my bad. So if you want to import multiple things from the exact same module, you just separate it with a comma. If you want to import multiple modules or multiple functions from different modules, then you just go to the next line and say from my whatever, import this else, right? But if it's from the same module, you just keep it in the same line and just separate it with that comma. Cool. Importing issues, right? If I import the following module and run this file, I get 15. Why? Look at the top code snippet and the bottom code snippet. What's happening and who can figure out why? The second bullet tells you. But go ahead.
I was just gonna say print is just gonna run automatically when you import that.
Why is that? Does anyone know?
You don't have, so print is calling a function already.
Yeah. So typically, when we import a module, same way that we're doing here, import calc, it's going to run the entire file unless you specify otherwise, right? It's going to import it, read it from top to bottom. And because on line 10, we're telling to print, it's going to run into that code and it will print it out. Now, there is a way to go around that. and that is going to be using the main function, right? If the file is imported, the double underscore name double underscore will equal the name of the module, and the file won't be executed. And I'll explain this in a bit. I know it's not a little confusing. If the file is run as a script, then underscore name underscore will equal main, so the script will run. So what does that mean? This was a little confusing for me to understand at first, so we'll run it together. And I'll explain what all this is trying to tell you. We'll create, we'll say num.py, and then we'll do my module.py, right? So in my module, I'm going to create the functions that I want to do, and we'll do something very simple, like define add, which will take x and y, and then it'll return to you x plus y. Define subtract x and y, return x minus y, and then we'll do something simple like define hello, which will just print hello. And then we can also print this is my module, right? So this is going to be the module that we're going to be importing into num.py. Let me go to it. Lesson 09. On num.py, I'm going to import my module. And let's see what happens when I run num.py. Well, when I run it, it did essentially what that slide showed, right? It printed out, this is my module, right? Because the moment it runs num.py, it gets to line 1, and it's imported in my module, and it runs through all the code, and it does it automatically. Well, how do we prevent that? Well, I'm sure you guys have probably seen something very similar to this. If double underscore name is equal to the double underscore main. Have you guys seen this before on code snippets?
Nope.
Well, no? Okay. So if you guys have, this is done to prevent it from running as a on its own, right? And then you could put this, right, the code that's supposed to run, only to run if your file is main. Now, what does that mean? Right, we run num.py and it doesn't do anything. Well, when you run your code, Python automatically runs that code, and the base name of your file is essentially name. We can do something like print main. I think this will work. Print name. There we go. If we print name, it's going to run the module. And when it runs that module, the module itself is printing itself out, right? What is the name of this module? It is my module, right? That is the name of this file. So this code on line 13, when it runs, it's going to check, hey, is the code, is the file that's running, is it the same one I'm in? And if so, print, print this my module. If not, then don't print it out. So that means when I import my module here, I'm not running my module independently. I'm running it through num.py. So when it checks on line 13 what the name of the file that's being running, it's gonna fail because it's not the same module, right? Because the name of this module is my module, right?
So if you were to run like Could you create a new Python file in that directory and name it main.py? And see what happens when you try to run it?
Sure. Import my module.
So I'm thinking that we should see, okay. Oh, I think it was in the wrong, oh, no, it's not.
There it is.
Okay,
So-
so, yeah, so, okay,
What's up?
so this is how you can actually, you can like have a bunch of modules, but based on what file you're running it with, it'll run specific code sets if you need it to.
Yeah. Right. And what this is doing is it's checking what file is running in, right? If we were to run this independently, then it should print out this is my module, right? Because when I ran the my module.py independently, it checks, is it the same file I'm within? Then yes, it is. So I'm gonna run this part, right? But when I run it in num.py, it doesn't run because it's not being ran independently as a script. Does that make sense? So if there's code within your module file that you didn't want to run independently, the moment you import it, you would put it within this if check, right? If else check. Typically, the way you do it is you create a function called main. Right? This is the standard way of doing it. You want to put it within a main function, and then within the if else statement, you would run main open and close parentheses. Right? So if I run this file independently, it passes this because it's the same file, it's being run as a script. Therefore, it will run the main function, right? Which is printing out this my module. But if I import the my module into a different file and I try to run that file, it won't print out that main function because it's not being run on its own. It's being run within somewhere else, right? So what it's checking is whether it's being run independently as a script or not. Does that make sense? It prevents your code from the module file to run whenever you import it, right? Unless you're running that file independently on its own, then that would be the only time it will run on its own. Does that make sense?
So so it seems like, so you're not going to always be using a module that you create. So are there ever instances where someone has created a module that doesn't have the function kind of encapsulated under a main function doing that check for you, that you then have to handle kind of like fixing their module? Because I've seen this before on code snippets, but mentally, I guess I was picturing it as something you handled on the main file that you were working from and not really the module, because you don't know who made the module per se. So there might be documentation you could read into, but you're kind of trusting that someone else set the module up correctly. That makes sense.
Well, I think that's what APIs are.
Yeah, I mean that's so this helps. For example, our instructor, one of the instructors that we have here for the immersive program, he automated the uploading of the videos from Zoom to upload onto YouTube on their own. So instead of having to go onto YouTube, go to his profile, create a new video, upload the file, add a description from the browser itself, he created a script using Python that does all that for you using the YouTube. He pinged the API, got his profile, and then I don't know how he did. He demonstrated to us, but there was too much code for me to understand at the moment. We just demonstrated it, but essentially, he created a script like that, and then whenever he runs that script, right? If you were to come into his terminal and he runs that file on its own, right, as a script, that main function would automate everything for him. If you wanted to use that module in another piece of code, and he didn't want it to run the moment he imported it, then that's when the main function will come into play. By using that main function, he's able to import that module somewhere else to use it on other projects and prevent it from running until it's time to run, right? That's kind of like the use of using the if name is equal to module main or not. Or does that make sense?
So are you saying it's standard practice to include this in your modules?
If you're creating a module and there's code that you want there to run only when you run it by yourself, then yes. You don't have to. It depends on what that module has, right? It depends the purpose of your program, what that file is. If it's supposed to run as an individual script, so you can run it whenever you want, then yeah, you would have the if name and whatnot. If not, then you don't have to. But people tend to use it, yes. Does that make sense? It's just a way to keep you or to keep your module from running on its own every single time you import it if you have code that isn't a function. If you have individual code that's doing something and you don't want it to run on its own, that's how you do it, by using this line of code right here.
So is there a way to handle that on the, I guess on the main file that you are running, the main program you're running? So I'm tracking putting it in the module, but from the main file itself, so the one you're importing the file or the module to, is there a way to handle, like, let's say someone else built a module and like the code is just going to run automatically, but maybe that's not what you want. So can you do that same if name equals main, run the function check on the main, or is it just purely something that happens on the module end?
As far as I'm tracking, I don't think so. But if you want to prevent that, just import what you need, just like you did here, right?
Okay, that's a
and
good
then
point.
I
Gotcha.
can get x equal to 5, y is equal to 10, and then we can do a print add 5 and 10. And then if we run this, we see it only does what the main.py was asking it to do, which is line 5. It didn't import this line or anything else besides the add function. So if you wanted to use a module that might not have it, that if name is equal to main, then to be safe, just import what you need. Right?
Gotcha.
Cool.
Hey, I have a question real quick. So whenever you import, is it importing it from that same folder or directory that file is in, or is there like a repository that it imports from, or how's that? Where's that?
It's
I remember
because
before I was had issues with that.
so because I am in this, right? So ls, did I go back? Oops. 09. Right, this is a directory that I'm in, right? So when I do Python main.py, and I'm importing the module within here, it doesn't have to look anywhere besides the directory. Because I didn't specify within here of where to get it. The first area it checks is the directory that it's in, which is all of this, and it is in there. Now, if I had a folder within here called modules, and I imported or I moved that my_module.py within that my module folder, extension Python wants to make refactoring changes with file, okay. And we kind of see here, it already automated, it kind of made it for me. It showed me the file path of where that module was from lesson 09.outofrange.modules.mymodule import add. So my VS Code kind of does it. If yours does it, then you'll have to manually type out how to get to that file path. So it's importing it from your own directory. But if it's not in the same directory, then you have to specify where it's at, right? Because it's going to check the directory that you're in, right? So when I run this file, it's going to run it because I'm in this directory. And if I'm importing some other module into this file, it's going to check the directory that I'm in. If it's not in there, it's going to give me an error, right?
Are you able to import modules from like a URL?
I'm not quite sure. Why it's not working? From my module, pretty sure. Let's see if I can do.
You forgot to add some module.
Oh, modules. Pretty sure something like this. I don't believe often. It's not liking this. Why is it not liking it? From my module.py for modules. Let's get the copy path. It's not liking it. I'm within here. It's because I'm using Ubuntu. I'm not quite sure. Give me a second. So if you don't have it in the same file path, then you have to yourself dictate where it is at. But it's not wanting to work on mine. What is the syntax for it?
Did you try deleting the /module/my module and just do a /?
Yeah, because it's in modules. That's my module. It's not working.
Yeah, that's weird. It definitely works for like HTML and JavaScript.
Yeah, that's why I'm confused of what's going on. Well, I'll figure it out. But we'll continue the lesson, and then once I figure it out, I'll get back to you. Sound good?
Yeah, that answered my question. Yeah, I mean, you have to, that answered my question.
Yeah,
Thanks.
essentially, you would have to specify the file path. I'm not sure why it's not working. I'll figure it out myself. Maybe where is this at? Out of range. It's because of that. Here we go. There we go. Jesus, I'm good, man. Anyways, it was a mistake, right? It was of how my folders were allocated. My bad. I didn't realize where I created a folder and the file. I was using the modules folder was within out of range folder, and I wasn't putting it where it should have been. Does that make sense? I was trying to find the modules.my module, thinking it was all within the same directory of lesson 9, but I accidentally put the modules folder within another folder, so it wasn't finding it. But here you go. So because they're not in the same directory, I have to specify where it's at. Well, it's in the modules folder. And then after I go into the modules folder, I need to go into it and grab the file itself. So that's how that works, Cody. It's not importing it from some like repository or somewhere weird in the cloud in someone's computer in China. It's like from your own computer. You just have to specify the location of where it's at. Cool?
Perfect. Yeah, thanks. Awesome.
All right. Moving on. So that takes care of the main functions. Essentially, all you're doing is specifying whether you want the file to run the moment you import it or not. right? If you don't want it to run the moment you import it, then you want to add the name equals main check. Therefore, it only runs the moment that you run that file independently. Cool. All right, so basic stats.py is going to be the first one. Let me delete this. Delete this. Basic stats.py. Oh, I already figured it out. All right, so for this project, you will import the statistics module, write a class called student that has 2 private data members. So you're still working with classes. The student's name and grade, it should have an init method that takes 2 values and uses them to initialize the data members. I'm not going to read it for you, but go ahead and give this a try, and we'll see how you guys do. All right, just for the record, I did not record about 15 minutes of the lecture. So upon completion of today's class, I will record everything that was not recorded for the purpose of the students who aren't able to be here present. But we are currently working on out of range.py. So let's go ahead and do that. I'm going to go ahead and share this myself. Since I know it's new, we can do it together. So can you guys see my screen? All right, so as discussed prior, we defined a class for our exception, and we named it out of range error. We didn't want to manipulate any of the attributes or functionality of the exception. All we wanted was to be able to classify, right, create some kind of error message, right? We didn't need to specific. We didn't want it to take any kind of argument parameter. So therefore, all we did was just put pass and didn't initialize anything crazy because we didn't need to initialize any of the functionality of it. We just needed the actual object itself of a class, right? The README asks for us to create a function called name the number, which will prompt the user for some form of input, which would be to choose the number 1, 2, or 3. And depending on the user's input, we would print out either 1, 2, or 3, or raise some kind of error, right? We see here that we did a try and accept block. On the try block is where I prompt the user for the input, and then depending on what I receive, I react accordingly. And then on line 13, on the else, is where I would raise my out of range error, right? If for whatever reason, none of these were it, or it did not pass, I want to raise an error. Now, there's a reason why I had to put this in here, right? Because it won't fail, right? If I didn't have the out of range error within line 13 and 14, it would go through the try block, and it won't fail if they put 4, 5, or any other number. Like, it'll still get through. It won't essentially meet the if condition, right? Any of them, but it's not like it didn't work, like there was an issue, right? It didn't fail at any point. Nothing was broken. So you have to put the else raise this error to let your code know that, hey, this failed, right? And because it fails, right, it essentially supposed to raise this error. And because it raises the error, then I'm catching it here, right? So I raise the out of range error, and then on line 15, I catch it, and I print out a message that's not one of the allowed values, right? Once my function was complete, I go ahead and test out the function. I even do it in a try and accept block. So in case I want to catch something like a value error, to show you that you can either do it in this manner, or you can even do the try and accept here without classifying any kind of exception. I use a standard value error message that comes with our code. And yeah, let's test it out. So we run this, it prompts us for a number. I'm gonna go ahead and put 4, and it raises the out of range error. The except block catches it and prints out that's not one of the allowed values. So that does what we want. And now let's see if the try and except block for value error works. So I'm gonna go ahead and add 1 as a string, and it responds with please enter a valid integer, right? So both of the errors worked, and that's kind of how this works. Does that make sense?
So you'll only ever need to use the raise keyword if it's a user defined exception or error.
Yeah, if you're trying
Because
to raise
if you're
error yourself, then yes, you will do it yourself. You will put raise because you are trying to make an error happen due to whatever the code said.
Gotcha. So like the accept value error has the raise kind of built in under the hood. You just don't see it.
Correct. Well, let me rephrase that. This is not wrong. There's nothing wrong here. There's nothing wrong syntax wise. There's nothing wrong name wise. There's nothing wrong value wise. So there's no error here. I am creating the error and I'm raising it if it doesn't do what I want it to do. Right? Out of range error is not a real error. I created this bad boy. So I'm gonna raise it where I think it fits in my code. Value error is a built-in error that comes with it. Like that's a common one. If your syntax is wrong, if it's the wrong value, right, or the wrong naming conventions because you haven't defined something yet, so your code will raise it on its own, right? The terminal will raise it on its own because it's built in the raise, right? Does that make sense? If I explain that well? Cool. All right. That takes care of out of range.py. Unit testing. Unit testing refers to testing individual units of code to make sure they work correctly before integrating them with your larger code base. Lots of modules available in Python for unit testing, but we'll be using unit test. It's going to be very similar to how we created a class and we inherited from the exception class. There is a class for unit test that's built in. This unit test module defines a number of assertions that can be used to verify whether a certain condition holds. All right, partial list on the next slide, we'll get to it. All right, so this is a small list of different assertions you can do. Essentially, it's in the name what it's testing out, right? If you assert this, that means you're checking between two values and seeing if they're equal, right? So this assertion will check if it's equal. This one will take two parameters and it checks if it's not equal. And this one assert true will take that one parameter and it'll tell you if it's true or not. So it checks something. It's a check, right? The assertions are checks that you're able to use in your unit test. I'm not going to talk too much about these because they're pretty straightforward. They're in the name, right? If it's not, if it's in, if it's almost equal, right? Check if it's within like decimal places, so on and so forth. The Python documents. I'm looking for a list of these. There's a lot more, but those are the common ones that they use. Here it is. All right, assert greater, greater equal, assert less. All it does when you create your function, you pass two arguments into your function. Like, hey, I want these two numbers, and then within that function, you use the method assert. You pass in those two numbers, and it will check it for you, right? That's all it really is. Here's a nice little example. Right, writing unit test syntax. You're gonna create a test file and import the unit test along with the file / functions you want to test. Right, on the right side, we see import unit test, right, because it's a built-in module with Python. And then in this file, you're going to import the functions you're going to be using, right? You're going to create a class that inherits from unit test.testCase. Time for. You can call the class whatever you want, but it's important that you inherit from the unit test.testCase module, right? We will cover inheritance at a later date. I kind of already talked about it, but we'll talk about it more. Inside the class, define your test functions with the appropriate assertions. Every test function needs to start with test. That is important. So when you start defining your test, it can't just be like, something random, like variables or different naming conventions. It has to start with test, right? Test _1, test _2, so on and so forth. You can add some comments here to let them know what this test is checking for, but it has to start with test 1, test 2, so on and so forth. Add the unit test.main function within your script conditional, right? This is where the unit test main thing comes to play. For you to run your test, you want the test to, to run only when you're trying to run it individually, right? So you should be able to run the file and it should run through all your code on its own. You're gonna run your test file with Python and then the name of whatever you call your test file. Actually, let's talk about this. Here we see a function called define list max. It takes in a list and returns to you the max number within that list, right? We create our main.py, whatever you want to call your test file. It could be whatever you want, right? Test.py, whatever you want. We create the class test list max. We inherit from the unit test.testCase class that we imported from. And then we created two different tests here. Test 1. This function names can be whatever you want. Test list, or whatever. So in this list, or in this function specifically, we have a list right here. We create the list, right? We just create something random to test it against to make sure it works. So we create essentially imaginary scenarios and we test it against it to ensure that it will work in all types of scenarios. Does that make sense? So you should be able to test this if you get a list of integers, decimals, a mixture of decimals and strings. So you would want to create different scenarios, like you see in test 2. This scenario has negative numbers. Test 1 has all positive numbers of all ranges. So through your test, you're creating different scenarios that you want to test against to ensure that whenever you publish your code and it's on live, and some bonehead tries to put something weird in your in your program, it doesn't break it, right? It actually does what it needs to do. Here we see what the result should be, right? So we create the thing that we want to test against. Here's my random scenario. Here's the right answer, right? And then you use the self dot and then the type of assertion you want to use, right? You use the self because this is the function. We're testing the class test. The method you want to use, you want to check if they're equal, and then you put the two items you're testing with, right? One being the correct answer, and one being which call it whatever this returns back to you, right? Same thing with test 2. The correct answer is -1. And then they test it against the result. And then this will return with you an error. And you'll see how that works in a bit. This is how the error will look like. the unit test output. If all 5 of your tests pass, it will tell you ran however many different tests in so many seconds, and then it'll give you an okay. Just because it's red doesn't mean it's wrong, okay? Just read what it says. If you fail something, it'll tell you the test that it failed, and then it'll tell you what happened, right? The assert equal. Assertion error, 17,000 or 1,700 does not equal 170, right? Pretty straightforward.
Actually, I do have a quick question. I'm having a brain fart. What is the difference between the triple quotes and the hashtag? Are they both comments?
The hashtag are comments. The triple quotes are for documentation. If that makes sense.
So,
I haven't done it, but there's a way that you can add documentation, and then you can screen your code, and it'll grab all the documentation, and it'll put it on a nice little like Word document for you of everything that you documented. I haven't done it myself, but I know that you can, right? So the documentation, I don't know how they do it. There's this thing that you can essentially screen your code, like run through all of it, and then it'll grab all the documentation that you created, and then it'll format it for you and create the documentation for you. So you don't have to manually go in there and create documentation yourself afterwards, right? As you code, you can add
interesting. Okay.
documentation. Yep.
Okay. So do that, just in case you ever figure it out.
Yeah. I haven't had to do it myself, which is why I have it. But yeah.
I'm gonna definitely have to do that at my job because we are piss poor at documentation for our apps. So
Where do you work?
I work at a place called Our Town America. We're like you ever seen those Val packs that people get in the mail, and it's like a bunch of coupons in like a envelope?
No.
Okay, well, there's a thing called a Val pack, and it's literally just a bunch of coupons to like a bunch of different restaurants and pizzerias and stuff. And basically, my company has a Val pack that we print and ship to people.
Okay,
So,
that's cool. Are you a software developer there or what?
I am a junior developer, but really what I am is I'm just a tier 1 systems engineer, and then I try to copy paste what I can to make things work as like a band-aid solution.
Cool, man. And you're all here trying to better yourself, huh? That's good.
Well, yeah, fuck yeah, I want to make more money.
Yeah, good stuff, man. All right, boys. Try multiply.py. Use the slides. If you want to reference these, the code snippets, or anything you might find online. If you have any questions, I am here, so don't hesitate to ask, and I can like help you out. As a matter of fact, let's break into groups so I can bounce around. I would like to help you guys out individually if you guys need help. All right, guys. Can you guys hear me?
Yes.
All right. So I feel like I just threw you guys in the deep end of the pool. So we're gonna go ahead and just try this out together. Okay, we're gonna do one test case, and then we'll take 5-10 minutes, and then you guys can create like 4 more. Okay? How does that sound?
Sounds good. I don't want to interrupt, but are you recording?
I am. Yes. Thank you for reminding me. Anyways, I appreciate it.
Because
Yeah. So all right. So first and foremost, if you feel like you're super confused, don't worry about it. All right, you do not need to be a subject matter expert at unit tests at all. The reason why it is in our FOP curriculum is because all your assessments are going to be tested against something like this, unit tests. Right, you're gonna copy down the assessment from a GitHub repo, right? It'll have
the assignment, and then there'll also be a test file in there that you will have to run, and it will test out your code. And if you don't know what these tests are doing, then you will be really freaking confused. I did not get to go through FOP. I didn't see unit tests until my first assessment, and I was freaking lost, man. Right? So the point of this lecture is to not get you to be writing 50, 100 tests and whatnot to make you a subject matter expert. It's for you to have some exposure to it and know what you're looking at. So whenever you get to the immersive program, you're checking, you're running your checks against your assessment, and you see assert equal and this is not equal to this, you know why it's not doing that. Because that means your function, somewhere along the line, it's not giving you the result that it should be giving you, probably because like it didn't give, and it's supposed to multiply everything and give you the result of that. Somewhere along the line, instead of an asterisk, you probably divided, right? Or it didn't do what it should have done. That's the purpose of this. So when you get to there, it improves your chances of success through these assessments to help you debug your own problems. You won't be writing any unit tests. At least, when I went through, we did it. I actually recommended afterwards that we should probably let the students write some unit tests their own so they can have an idea of what it's doing. But I don't know if that's going to be a thing or not when you guys go in.
Hey, I did it.
All right, so we're going to go ahead. We're going to import unit tests so we can have access to the class. And
I don't think
then,
you're sharing screen.
okay, let's see. Share. Let's actually create. Can you guys see my screen now?
Yes.
We'll do a test file. The readme said we have to write a function named multiply three numbers that takes three parameters, multiplies them together, returns a result. All right, so pretty straightforward. We'll do that. Define. Oh, what happened? Takes A, B, and C, and then return A times B times C. All right, pretty straightforward. Let's get to our test file. From multiply, import, multiply underscore three underscore numbers. All right. So we now have the unit test module imported, and we have the function we want to test against. So we can go ahead and create our test class, which will be, we'll call it test multiply function, and then unit test dot test case. All right. That'll be the class we're inheriting from the test case module, and then we can go ahead and define our very first test. So we'll do test one. We'll give it self because it's within a class, and then we're going to do something like result. Right? Result is going to hold the response of our function. So now we actually want to use our function. We're going to do multiply three numbers, right? We're going to run the function within this test. We'll do 2, 4, and 6. And then whatever my code returns should be saved within this result. And now I actually want to test my function. Make sure that it's actually multiplying what I want for it to multiply. So we can do self dot assert equal, right? I want to test whatever comes back to my function, and I want to ensure that it's actually what it should be. So if this is 2, 4, and 6, 2 times 4 is 8. 8 times 6 is what, 40? I think 40. Quick math, right? So it should return to me 40. So multiply underscore three numbers should return to me 40. In my assert equal, I'm grabbing what it should return and what it returns from the result, right? I'm going to test these two against each other, and if done correctly, it should pass. Let's say I didn't do it correctly. Instead of the asterisk, I put a freaking plus sign, right? So if it runs this test, it's going to get to this point 2 times 8, I'm sorry, 2 times 4 is 8, and then plus 6 will return to me 14. Therefore, this should fail, right? I don't, where am I? CD8P. And then Python test. Oh, we want to run as a script, so we have to add the script part. And it should be unit, I believe like unit test something. Unit test main. Where am I getting this from? This is just a syntax for it. You can check out the documentation. But yeah, so now we can run the file. It should run as an individual script, and it should give me a result. Well, here we see we ran one test in 0.001 seconds. I can scroll up and it tells me the tests that it ran and which ones failed. It failed test 1 because 14 does not equal 40, right? So what does that tell me? It told me that I messed up somewhere in my function when I was coding along, right? That's what test production looks like, right? Like when you build using tests, you go back and you use all these tests to test all the code that you created to ensure you didn't make any kind of mistakes. Well, thanks to this test that I created, I know that somewhere in all my code, this function from test 1 that's being tested does not work and it's broken. So I come back to my code. Oh, I see. That's where my mistake is at. I can come back and then write and then run it again. What the heck? Oh, it's 48. My bad. Dang, no one said anything. Making me look dumb on camera. All right.
This
let's
shit's
go.
hard, bro. What do you mean?
Yeah, we all look dumb. Are you kidding? That's all of us. That's on us all there.
It just made the test pad, so I wanted to see the fail.
All right. All right, so now we run it. Ran one test in 0.0 seconds. Okay. All right, that means we passed everything. That's how test works, right? Let's say I wanted to create something. Oh, by the way, I looked at the comments thing, Brandon. Another thing that helps for is to write comments and on multiple lines, the triple quotes.
So it's documents and multi-line quotes?
Yep.
Okay.
So you don't have to keep
So-
putting the hashtag. If that makes sense.
Dang,
Everything
so-
between the 3 quotes allows you to comment.
So it sounds like hashtag would be used for like personal, informal commenting, and then the triple quotes would be for technical commenting.
Yep. Here's another one. So that was one test. Let's check out another test. We'll do self. Oh, test 2. Self. I'm going to test out the same function again. You guys can create different functions if you like. This time I'm going to grab different ranges. I'll even add a negative in here. Actually, let's do ranges instead. Self.assert equal. I should be able to get the result. Let me do the quick math for this. I don't want to mess it up. I look though. What is this? What did I put? 10,000. That's 50,000 times 20. I'm sorry, 200. 50,000 times 200. That's way too long. Let's lower this. And let's put something different. Cool. 500 times 287. It should return to me 143, 500. All right. So I ran both tests. Both of them passed because my function was created correctly, right? If for whatever reason this doesn't multiply like it should, then both these tests should have failed, right? I can also test with negative numbers, see how that works. 100 times negative 5 times 287. Oh, it's the same thing, just negative. Dumb. And so on and so forth, right? So all your tests are doing are essentially taking the functions or whatever your code should be doing, and then you're adding the right answer that it should do, the outcome that it should have, and then testing against itself to tell you if it worked or not. Right? You're creating different scenarios that it should be able to pass, essentially saving you. And right now, it's not a big issue because it's only 2 lines of code. The issue is when you have 200, 300, 400 lines of different code and all types of functions that should be doing multiple things, you know, how are you going to test all that? Well, you create unit tests. It would suck to have to go through every single one of all your functions and or create different objects, or actually try it on a live server or whatever. Like, you do it here, right? You do it here on your unit test. You give it fake scenarios, so you ensure that the functions you've created do what they should be doing. Does this make sense? It is not just equals or not equals. You can do if stuffs are false or not. If values are zeros, less than equal to. It's a variety of different things that you can test against. But that's how that works. Don't overthink it. Just know that whenever you're running your test, you actually have to use the function, get the right answer, and then use the assertion against itself. Cool? What if you were creating object? You can also do something too. If you're trying to check classes to make sure your classes create objects that should be created or have the value that should, you could do the exact same thing. You can test against objects. You would essentially instantiate an object within here, and then compare it against whatever it should be. You can do all that. Cool. Take the next 15 minutes to create 4 or 3 of these tests, and then take a break. And we'll continue at 8. Sound good? I'm sorry we went over the breakout time. I just want to make sure that we kind of wrote 1 or 2 here so you guys kind of saw how it's supposed to go. Awesome. All right, guys. Let's come back. How was that? Was that better this time around?
Yeah.
Awesome. How about the rest of y'all? Good? Cody? Yeah? Better? All right. Yeah, I just want to make sure that I reiterate, man. If you guys aren't, feeling so confident with unit tests, it's fine. You won't really have to use it much until you get to your first job. All right. For the immersive program, it's not a big deal. If you understand it, then that's even better. Some of the questions that I got during my interviews were like, do you have any experience with like, test development? Because that seems to be very popular with like, when creating code in a lot of these, different work environments, is that they use test development to teach, build their code off of stuff. So if you have some kind of familiarity with it or you know how it works, then it's a plus. If not, it's not a big deal. It's mainly just for you guys to have some familiarity with it, so you're not lost when you're running your unit test against your assessments, right? Hopefully this does help and gives you an idea of what to look for whenever you do fail your test. And then as well, what's going to help as well, just by creating these unit tests, is that if you're failing the unit test, you can go through the unit test file itself and find the unit test that you're failing and see how is it built, what is it testing for, right? You can see what the function is checking and what the right answer should be, and whatnot, and how it's built. and maybe that can give you some insight of how you can go back to your code and kind of fix the issue. So knowing the syntax behind it, how it's built and whatnot really helps out in the future. Cool? All right. Let's go ahead and share. So that concludes multiply.py. All right. Next is going to be the last assignment for this lesson. It's going to be LemonadeStand.py, which will take the rest of today and a large portion of tomorrow. So let's check it out.
Hey, Roger.
What's up?
I actually have to step out. So
Okay.
I'll see you guys tomorrow.
Sounds good, brother. You take it easy. All right, so LemonadeStand.py. It's a pretty heavy one, as you guys can see. So we are gonna break up. How many people we have right now? 5. I guess we won't break up into groups until tomorrow. But I will be bouncing around. All right, so you will be writing code for recording the menu items in daily cells of a lemonade stand. All right, it will have the classes menu item, cells for day, and lemonade stand. All data members of each class should be marked as private, a leading underscore in the name. Since they're private, if you need to access them from outside the class, you should do so via get or set methods. I recommend to, at least for me, it helped when doing this, create different files, one for menu item, one for cells for day, and then import those into your lemonade stand. So whenever you actually build the stand itself, you have access to everything from the other classes. That way, it helps separate all the concerns and you don't feel overwhelmed with all the code you're going to be writing. Okay. You also have a test file. It has, I believe, like 10 of these. 1, 2, 3, 4, 5. Oh, 5. All right. So I guess just 5. You have 5 of the tests in here. I see that from Lemonade Stand, there's an issue here. It's probably the way that it's named. So you might want to change this to Lemonade Stand to ensure that you're actually importing what you need to import, right? So just fix that. I think that's the only issue on this assignment. So if it's not working and whatnot, check the imports because you probably have the typo that I have. If not, you should be fine. But if you import menu item and sales items or whatever you're going to use to lemonade stand, when you import a lemonade stand, you should be able to still import everything else. Cool. This will be the remainder of today. I will close out breakout rooms around 8:50ish, and I'll bounce around. If at any point you encounter any kind of issue, please raise your hand in the Zoom channel, and then I will get to you as soon as I can. I'll probably be busy with another student. If not, let's get to it. I bet I fat fingered that. All right, so our class kind of got a little bit smaller while we're in the breakout room. Some people had to check out, no biggie. But it is 8:52. We got like 8 minutes left on today's class. Hopefully you guys got a lot done on the LemonadeStand.py. This will take a large part of tomorrow as well. So if you guys didn't get too far or if you feel like you're struggling, don't stress it. Tomorrow, on top of giving you guys some time to do it, we will do a walkthrough of it, where I will code along and you guys can see as I code the thought process, watch me make my own mistakes, and then we can just learn together as a whole. And yeah, you kind of get to see the viewpoint of somebody else who's done it before. Any questions before we cut for the day? Anything that you guys might have encountered, some kind of issue?
something that you maybe didn't click right yet.
Is this more equivalent of like something that we'd see during the immersion program?
Yes, the LemonadeStand.py is pretty close to what you'll see. The one in the immersive program will be a little bit more intense than what this is. They'll have some other stuff on it that you will also have to do. But this is very similar. The immersive program one will be I feel like saying, this on steroids, but I feel like it'll be overkill. It's not that bad. But essentially, if you can get through LemonadeStand.py and you feel pretty good with it, and this being the first time you guys seeing it, the next time you do see it, it should be significantly easier to handle. Even the people that went through FOP actually hit me up when they were going through the immersive program. I've had multiple people tell me like, now I understand like what you were talking about when it came to oriented programming, yada yada. So I feel like maybe because I'm thinking back to it, I don't think it was too bad. But those people that went through FOP, they still thought it was pretty heavy of an assessment. So I don't know, to each their own, but today's lesson, the LemonadeStand.py, the walkthrough tomorrow, and then the Space Invaders clone that we're going to create next week should give you a pretty good foundation and understanding of oriented programming, object-oriented programming. But yeah. Any questions about the actual assignment? Anything that you might have ran into that you're probably stuck on right now that you guys want to cover real quick? Okay, awesome. Feel free to work on it tonight, tomorrow morning, afternoon, whatever, before class if you want to. Like I said, you will have some time. I'm not gonna give you too much, no more than an hour. That we'll focus on this again. After that, we'll do the talk through walkthrough, and then we'll leave LemonadeStand.py behind us. But if nothing else, you guys have a good rest of your night.
Thank you.
Thanks, you too.
Thank you.
Thank you. All right. As promised, unfortunately, during the actual lecture, I was not recording when discussing a certain part of the curriculum, which involved exception handling. So now that class is over, I'll do a quick little talk through of what was discussed and missed. Essentially, we covered exception handling. There are two things that will stop the program and print an error message. One of them being the syntax error that you guys are probably very familiar with, which is forgetting a colon or something being misspelled. Other stuff that you might have encountered up to this point, probably name errors, value errors. But another one that you're going to see is going to be exceptions. All the other errors that stop your program and print an error message. Maybe your function didn't get necessary input or something was not defined. But exception handling is pretty cool because we're able to create our own exceptions and create our own errors to debug our code. Sometimes something like syntax error or a name error can be too vague, and we want to be a little bit more specific to the code that we've created. And creating our own exceptions allow us to do that, right? Here we see a very small example of how we can use different types of errors. We have a try and except block. On line 1, we have a numerator. On line 2, denominator. Line 1's numerator is 10 to being cubed, while the denominator is requesting input from the user. And then we're going to be checking that input. On the try and except block, as mentioned before in previous classes, when using a try and except block, if at any point your code runs into an issue, it cannot pass any line of code or there's some kind of break, it'll immediately go into the except block. We see that here on line 5, where we grab the numerator divided by the denominator, convert it into a float, and then print it. And in the event that this did not work due to the fact that there was probably 0 use, it should break, and we would use the except block to raise a 0 division error. We see that here in our terminal. when they enter the 0 for the denominator, and it raised the 0 division error, printing out the message that was added on line 8. Raising user-defined exceptions. So most of the time, you don't need to raise a built-in exception. You can just define your own. We see that here on the right side. We are creating a class named imaginary number error that is inheriting from the exception class. Now, inheritance is a little bit out of scope right now for the class, but essentially, Python already has an exception class, and to inherit from that class, we use the opening and close parentheses with the class name being exception, and that allows us to use that class and its different attributes and functions. We're not trying to use anything specific or override any of its methods or functions. Therefore, on line 3, we're just going ahead and using pass. But this at least allows us to create an exception. By inheriting from the exception class, it makes this class into an exception, which we can use ourselves. By naming it what we wanted to, we were able to customize it to say imaginary number error. Here we see on line 5 user input. It takes input from the user where they're asking for a positive integer. On line 7, we use an if and else. If the input received from the user is greater or equal to 0, then we would want to get our final result and multiply it by square it to 0.5. In the event that it is not greater or equal to 0, we raise our customized exception, imaginary number error, which they here being happening on the terminal where they give it -5, which did not meet the if else. Therefore, it raises imaginary number error, and that's about it. There's no other functionality added here. We didn't customize or change anything in the exception class, and we didn't ask to print anything specific out. An example of this, give me a second, of how we can use the exception. Stand by. I have a code snippet here that I found from the internet that gives a pretty good example of how we can customize our own exception classes. If I could just find it. Okay, here we go. Let me share my screen. Unfortunately, this was not in your slides, so I had to do this own research myself to give you this bit of information. So here we are creating a class called salary not in range error, and once again we are inheriting from a pre-built class from Python called exception. But here we actually want to be able to make it a little bit more customizable to the use that we want. So we're going to try to override some different attributes that this class exception has. We create a init method where we pass 2 different parameters, one being salary and one being the message. Well, the default of salary is not in 5,000 to 15,000 range. After that, we're able to assign it like usual. And then we see a line here called super open and close parentheses init. Essentially what this line is doing is we are initializing the attributes and methods that come from exception. A good reference is using kind of like like the superheroes, right? So typically when a superhero, right, in the comics, if you think back to it, when a superhero has a kid, they pass down their superpowers to their child, right? But typically the kid isn't born with the powers right away. They tend to develop them over time, or essentially they accentuate over time, right? In this situation, we're doing something very similar. We're creating a child of the exception class. The exception is our parent. The salary not in range error is a child that we created from the exception class.
But if we want to use any of the attributes or methods, data members that exception might have, or anything around that range of stuff, we need to initialize the functionality behind exception. So we do that here by the super init method. This in turn allows us to use the functionality behind exception. Think just like the superheroes. If the kid wants to have the death power, he has to awaken them, right? We're essentially just awakening the exception that we're inheriting from. That's what that line is doing. And then when we actually need to use it, because we customized that exception, we're actually able to give it some kind of specific input like salary. Therefore, when we see here, when the actual output is given, it raises the salary not in range error. And then it even gives us the message, right? Thanks to the init that we have here. It prints out the message. That pretty much concludes what was missed during the lecture and what I've forgotten to record. But yeah, thank you.